Topic 6-2. This can be referenced with the Holt textbook, Chapter 6, Section 5, page 418 through 425. This section is going to be on rectangles. We're going to go through some of the definitions. A rectangle is a parallelogram with 4 right angles. But to determine, the theorem states that as long as one angle of what's already been determined as a parallelogram has a right angle, then it is a rectangle. So notice, if it's a parallelogram and you make one angle right, a 90 degrees, you now have a rectangle. Because a rectangle is a special type of parallelogram, it has all the properties of a parallelogram. So let's list those. Opposite sides are parallel. You can show that with arrows. I'm just showing a picture parallel to this one. Opposite sides are congruent. That can be shown with marks through the segment. Opposite angles are congruent. That actually can be shown with all right angles because it is a a rectangle. Consecutive angles are supplementary. We know this because consecutive, again, is walking around the figure itself. This is consecutive to this top one. This angle is also consecutive to the left bottom one. Those are supplementary. In a rectangle, they're all 90 degrees, and we know that 290 degrees is 180 degrees. The diagonals bisect each other. If you took, let's try a blue pen, the diagonals of a rectangle, they bisect each other. The difference in a rectangle and a parallelogram, however, is, notice that when you bisect the angles of a parallelogram, they are only congruent from this segment to the middle segment and this segment to the end. Same thing here. The shorter side from the end point to the middle bisector to the other one is congruent, whereas on a rectangle you've got congruency all the way across. This is congruent to that, and that is congruent to that. So sometimes you're asked to find this being congruent to the segment of the bisector here. So keep these notes, and they'll be at the back of the topic answers also. However, the diagonals of a rectangle have an additional special relationship. If we name the diagonal of this one here, you have LN and ON. I'll highlight those if they're shown with a dotted line, but you can also highlight it. Alright, to find the lengths of these diagonals, we're going to use the distance formula. If you go through and plot each one of these points, it's done for you, and find the distances from OM and LN, you're going to discover that they both have lengths of square root of 149. Therefore, we can say that a parallelogram is a rectangle and its diagonals are congruent. And again, I showed you the difference in a parallelogram and a rectangle, showing that this would be, the diagonal is actually congruent to that diagonal. Not so in a parallelogram. They bisect each other, but they do not show congruency. So that's the special relationship of a rectangle. Okay, look at the next example. Quadrilateral MNOP is a rectangle. So MO equals the 2x minus 8, and NP is 23. So if the diagonals are congruent, we can highlight them again. This whole distance was given to us along with this whole distance set them equal to and solve, and you get x equals 15.5. I'll give you a minute to work through those. You're welcome to pause this at any time. This example, the same thing. LJ, the whole distance here, is congruent to KM. Therefore, the diagonals bisect each other. For this one, they want you to find the value of the x. Well, they've only given you LP, so be careful. They only gave you this distance from here to here. Therefore, you have to say that you have two of your LPs. So if LP was given to you as 3x plus 7, it's two of those. Distribute the 2 to get this and set it equal to what was given as the whole distance of that diagonal, since they only gave you part on that one. So that one's a little bit tricky. The last example, moving this up a little. Again, the diagonals are congruent. If AC was given to you as the whole thing, and they're wanting to find the value of x, but they only gave you, well, I'll go ahead and show the two diagonals being congruent, but they've only given you dp. So if they only gave you dp, then again, two of your dp's is going to make up this entire segment of dB. So again, you have to make note that you have to have two of what was given to you as x plus 7. Distribute 2x plus 14 and set it equal to what they had given to you as AC, 4x minus 13. Walk through solving it for x, and you would get 13.5. Okay, last example. If this rectangle is given, find the following information. Well, they gave you that the measure of 1 is 70, and the angle 1 is 70, and the measure of angle 7 is 70. So the only ones they actually gave us is this one here, and 7, this one here. Well, because we know that these form right angles, which we can show, this is a right angle, then it's complementary, and that's why we know that this is the 70 plus the 20, which gives us a 90-degree angle. So therefore, you can walk around the entire rectangle, 70, 20, because this is 70, alternate interior angles, that one's 70, alternate interior angles of two transversals, which the diagonals are, also give these 20. So again, walk all the way around. How they got these were, you can look at any triangle individually. So we can look at this one right here. I'll highlight it. If you looked at just this triangle and the base angles are both 20, which we were already given, oops, not looking up, then the base angles being 20 and 20 is 40. Well, in a triangle, all of them have to equal 180, so you've already got 40, so now 140 more would have to be your angle 10 in order to get this angle measurement. Vertical angles are the same, and then if you were to figure out that that's 40, it's because this forms a linear pair. You've got this angle here forms a linear pair with this angle here. That's why C is 40. This would have to be 40 because of vertical angles. So all of these angle measurements can be gotten that way. All right, filling in a few more summarizations of properties. 1, the properties of a rectangle, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, and diagonals are congruent. So I'll give you a minute to do that one too. And that concludes 6-2.